Howdy, howdy, folks. Welcome to Psych 652 Lab, Module 8. Today we're going to be talking about matrix algebra and multivariate correlations. Now, I'm going to assume that a lot of this is new to y'all, so I went ahead and I prepared a little slideshow beforehand to kind of talk about some of the essential concepts of today's lesson. So today, for my objectives, I have that we're going to first talk about what matrix algebra is. Then I need to teach you a concept called indexing from a matrix in R, and then we'll talk about multivariate correlations. So let's start off with matrix algebra. So today we'll be working with matrices in R. And essentially, overall, a matrix is a two-dimensional array of numbers. However, in R, a matrix, which is more specifically, is a matrix requires that all of your data take on the same type of class. So that means either they're all character class, or they're all numeric, or they're all logical. However, for today, we're going to make sure that they're all numeric class. And what happens is, when you have all your data in a specific class in a matrix form, you're allowed to perform matrix algebra in R with it. And this is what separates it from a data frame. A data frame can't do these multivariate correlations or matrix algebra because it doesn't know what type of class each thing is. So we're going to be able to do this with our matrix algebra in using matrices in R. So today we're going to be using matrix algebra to obtain a multivariate correlation, which is essentially a correlation with multiple x's and multiple y's. So how does matrix algebra work? So let's take this visual example for once, where we're going to be multiplying two matrices by each other. So you have matrix 1, which is a 1 by 3 matrix. You have matrix 2, which is a 3 by 4 matrix. And what I mean by that 1 by 3 is that it takes on one row and 3 columns. Essentially the same thing with this 3 by 4 matrix. It has 3 rows and 4 columns. And what we're going to be doing is multiplying these two together. So if I want to multiply matrix 1 by matrix 2, I get this outputted matrix, which is a 1 by 4 matrix. Notice that it takes on the number of rows from your first matrix and the number of columns from your second matrix. And that's what it becomes. It'll always come out that way. It'll always be the number of rows in your first matrix and the number of columns in your second matrix. So when we're multiplying matrix 1 by matrix 2, all that's happening is that this 3 is first going to the first column in the first row and multiplying that. Then this 4 is going to the second row in the first column, and then the 2 is going to the third row in the first column. And then it does that for this column, and this column, and this column. So this 3 times 13 plus 4 times 8 plus 2 times 6. So as you can see, it's a summation of the product of these three terms from here. In order to get this 63 over here, it's 3 times 9 plus 4 times 7 plus 2 times 4. And then the same with the 37. So it would be 3 times 7 plus 4 times 4 plus 2 times 0. And we're going to be using this to obtain the multivariate correlation, which is in the multivariate equation is up here on the right, which really just indicates that you're multiplying matrices by each other. And I'll go into more detail on it a little bit later. Now we need to talk about another concept called indexing variables from a matrix in R. So in R, we'll be doing indexing from a matrix. This is equivalent to selecting and filtering variables via select and filter from the tidyverse package. However, since we're working with matrices, select and filter won't work on these matrices. We won't be working with a data set at all today. We're only going to be working in matrices. So instead, we need to tell R which variables we want with this bracket, comma, bracket method. And I can show you how it works right here below. So you get some sort of matrix, and then you do a bracket, and then you have a comma. And to the left of that comma is what rows you want from your matrix, and to the right of that comma is what columns you want from the matrix. And I provide some examples on the next slide of what's going on here. So here's some examples. Let's say I want row 2, column 3, which is one exact observation from some participant on a certain variable. So the way I do that is do name of my matrix, bracket 2, comma 3, and bracket. That's going to give me row 2, column 3. Let's say I also just wanted the third column and every single row. Well, the way you do that is to the left, you indicate a blank you just have nothing, and that says, okay, I know that you want every single row from the third column. And you can do the opposite where you can get the third row of every single column. And then additionally, we can use a colon to indicate that we want an array of rows and an array of columns. So essentially when you see that the colon, just think here to there. So in this matrix, our fourth matrix here, we're going to get the rows 1 to 3 and columns 2 to 4. So this matrix takes rows 1 to 3, see, as we can see, 1 colon 3, and 2 to 4, columns 2 to 4. And then lastly, we can combine these colons and this lack of a number in order to get every single column. So here we want rows 1 to 5, comma, and every single column. And up on the top right here, I show it in action in R. I found this online. So you have some sort of matrix called M. And this is what matrix M looks like. If we wanted to select just the third row, we would do M bracket 3 comma blank, and that would give us every number from the third row. Now let's say, for example, we want just the third column. Well, we do M blank comma 3, and we get 3, 9, and 14, which is just the column 3 of our matrix. So some notes associated with indexing. Indexing can also be done on data frames, and it's quite efficient, and I actually use it every now and then. But select and filter are much more intuitive to use, so keep using those whenever you're working with the data frame. We won't be using them today because we're going to be working with matrices, but select and filter are just so much more intuitive and easier to read when someone's coding. We won't be, and if you're feeling confused on indexing in general, we actually won't be using it that much in this class. It's mostly just for this module where we're going to be doing some matrix algebra. Now I wanted to kind of talk about multivariate correlations. So multivariate correlations is the correlation of 3 or more variables. The goal of today's activity will be to find the multivariate correlation of a series of x's, so your predictors, and multiple y's, which is your outcomes and criteria. And additionally, we're going to learn how to weight variables. We'll be showing you how to weight variables, but we won't actually be weighting them because we'll be setting everything to 1. But essentially, if I wanted to say something is 2 times as important, the way we'll be doing is I put a 2 instead of a 1 or something like that. But we're going to keep it kind of normal so we get the optimal weights. So this is the main equation that we're going to be working with today. And I know that it looks pretty intimidating, but it's actually not that bad when you think about it. Really, all this equation is getting a series of correlation tables that we'll be dividing and multiplying and taking the square root of, essentially. So on top here for your numerator, it's the weighted correlation matrix of anything that correlates x and y with each other. And on the bottom in blue, we have the correlation of all of our y variables. Because remember, we're going to be working with multiple y variables. And then in red, we have the weighted correlation of any of our x variables. And keep in mind, those weights are chosen by you. You can choose whether you want it to be weighted. If you don't want it to be weighted, it'll just be a series of 1s. If you want to multiply something by 2, you can put a series of 2s in there as well. But just know that those weights are chosen by you. All right, so let's go ahead and start coding today. So per usual, let's go ahead and open up our RStudio. We're going to create a project. So new directory, new project. We'll name it module _08. Go ahead and create that project. And we're not going to be working with any data today, and we're not even going to be loading up any other packages today. We're going to be working in base R all the way today. And we're going to be doing a new R notebook. Go ahead and delete all the unnecessary text. Let's go ahead and name our notebook. Let's name this Matrix Algebra and Multivariate Correlations. Okay, and let's go ahead and, per usual, get our table of contents ready to go. Okay, so I'm going to go ahead and save my notebook. Save it. Module 8 notebook. Save. Okay. Go ahead and load up some notes here. Okay. So today's going to actually start off a little bit differently. We're going to go ahead and start off with a problem. And I'm going to say this is actually something that I think Kevin is actually going to already be presenting to you, but I'm going to go ahead and go in a slower pace and kind of detailing everything about it. But we have some sort of problem today. So let's go ahead and say, I'm going to go ahead and copy and paste this in here too real quick. Just give me a second here before we start. Perfect. So So we have some sort of problem. So suppose you find a study that provides correlations between the measures of academic qualifications. So there's three X variables. There's a high school GPA, there's SAT math, and SAT EBRW. I'm actually not sure what that EBRW is, but just know it's another SAT score. And two measures of college success. So these are our outcome variables. So our Y1, which is college GPA, and GPA in their math courses. And this is what the correlation table looks like for that. So they correlated three X variables and two Y variables with each other. Now, what our goal for today is we're going to find the multivariate correlation of all of these variables together. So we're going to have to find, remember from that equation, we're going to have to find the correlations between all of the X's, the correlations between all of the y's, which is actually down here, where the y variables correlate with themselves, and the correlations of the x's with the y's, so the x's with the y's, which is down here. And we're going to be separating out this matrix so that we can get that total matrix formula to get the multivariate correlation. So what I'm going to do today is we're going to divide this into steps to solve this problem to get this multivariate correlation. So I'm going to create a new header, and it's going to be steps to solve this problem. It's going to be a little bit different than you're used to seeing things because we're working in matrices today. And we're going to start off by just setting ourselves up for the matrices. So let's go ahead and create a step one, hashtag step one. So our first step is going to define the number of x and y variables. Okay, so here we go. We're going to go ahead and create two new objects. One object where we define how many x variables there are. Another object is defining how many y variables there are. And we're going to be utilizing these later. So let's go ahead and create a comment here. So we have three x variables. Save it into an object called quote nx. Okay, so what we're going to do is create a new object called nx, which stands for the number of x variables, and we're going to say how many x variables there are. So there's 1, 2, 3 x variables, so it's just going to be 3. Next, we're going to say I'm going to create a comment. We have 2 y variables. Save it into an object called ny. So we're going to create a new object called ny. It's going to be how many y variables we have. We have 2 y variables. So I know that this may not be clear why we're doing this, but you'll see later we're going to be utilizing this nx and ny variables in order to help us index our matrices. So we're going to go ahead and press play here. And voila, we have two new objects in our global environment, one called nx and one ny. One nx is 3 and ny is 2. So let's go ahead and do the step 2. Step 2, which is add in calculations to help R identify start and endpoints. So we're going to be using this so that R is going to know what matrices, what we want to pull from this matrix essentially. There's going to be a part we're going to be pulling where all of the x variables correlate with just the x variables, another part where the x variables correlate with the y variables, and another part where the y variables correlate with themselves, which is exactly where the places where I've circled. So we first comma, allow R to identify how many columns in total there are. And the way that we get that is we simply add up nx plus ny. So this is going to be called ntot. We're going to create a new object called ntot, which stands for the total number of columns. We have 1, 2, 3, 4, 5, or 3 plus 2, which is going to be our nx plus ny, which is essentially saying add 3 and 2 to each other and save it into a new object called ntot. And tell R where the y variables start, which is just nx plus 1. Okay, so we're going to create this thing called first y, and this is going to tell us where the y variables start, and we're going to be needing these for when we index later. And all this is nx plus 1. Now it's very important that when you set up these matrices that it set up all the x variables first, then the y variables. So what we're saying with that nx plus 1 is we're saying that our y variables start on the fourth column. So it's whatever the last x column is plus 1. All right, so we're going to go ahead and do this. Voila. We have first y, which is 4, so it's telling it that y starts at the fourth column, and in total, which is how many columns we have, which is 5 columns in total. And we'll be utilizing those later, you'll see, when we start indexing variables. But first, we need to do step 3, and I'm going to go ahead and change these to second level headers. So we're going to go ahead and do another second level header, hashtag, hashtag. This is going to be step 3. Enter the weights for the criteria and test variables. Okay, so we're going to go ahead and create a new R chunk. And for this, what we're going to be doing is going to be setting weights. What we're saying here is, are any of these variables more important than the others? And for now, we're going to say no. And we just want the standard multivariate correlation without any weights added into it. So we're going to go ahead and set our criterion weights. So criterion weights. And criterion is just another fancy way of saying the outcome variable. So I'm just going to put in parentheses the weight for the y variables. And so what we're going to be doing here is setting up our first matrix. So the way you create a matrix in R, well, first let's go ahead and name our object. So we're going to name this matrix C weights, which stands for criterion weights. And the way that you create a matrix in R is you type in the word matrix in all lowercase, parentheses, and you use something called a concatenate function, which is C with parentheses. And what we're going to say within this concatenate is say we want the values of 1.0, comma, 1.0. So we want a matrix that contains 1 and 1. And these are the weights that we would set to our y variables. So if we thought one of these y variables was twice as important as the other one, we would change either this first one or the second one to a 2. Additionally, outside of these parentheses, we need to indicate how many columns are in our matrix. We're going to do incol equals 1. So we want a 1-column matrix with 2 rows, essentially. And we say comma I row equals true. And essentially, all that's saying is that we are going to create a matrix with the values 1 and 1. It's going to be 1 column, and it's going to be by row equals true. It's saying set this up by row. So this is going to be the first row, and this is going to be the second row. Okay, and let's go ahead and just run this line of code, and I'll show you what happens. So you have a new matrix called C weights. If we click on that, you can see it looks like a data frame, but it's not quite a data frame. But it created a matrix that has 1 column and 2 rows. And again, this isn't a data frame, it is a matrix object. Okay, so we set the criterion weights. Now, we're going to do the same thing, but we're going to do it for the weights for our predictor variables, which we're going to call the test variables. So let's go ahead and create hashtag test weights. I'm going to put in parentheses x variable weights, x variables weights. So we're going to do this, but now this is going to be a matrix with 3 1s in it because we don't want to add any weights to it, but we just want to have it for later. So we're going to call this T weights, and then into that, make an assignment operator. So we use the matrix function, parentheses, use our concatenate function, which is pretty necessary to have within your matrix function. And we're going to do 1.0, comma, 1.0, comma, 1.0. And all that's saying is that we don't want to add any extra weights to our extra variables. We want them all to be multiplied by 1. And then we again do incol equals 1. So this is going to be a 1-column matrix. And then by row equals true. Okay. And that's going to say we're going to create a 1 by 3 matrix. Or a 3 by 1 matrix. I'm sorry. A 3 by 1 matrix, which is going to be 3 rows and 1 column. So if we run that, we have this other data in here called p weights. And as you can see, again, it is a matrix and it's not a data frame. It's going to have just a series of ones. Okay, so there we go. And the next thing we're going to do is do step 4. We create a matrix. So we go ahead and insert new arc chunk. Now we can normally, oops, there we go. So we normally could create our own matrix, but I'm going to go ahead and just help you all out for this creating a matrix because it's going to be a big matrix. We're actually going to be creating this matrix up here, and that would be a lot of numbers to type in, right? So I went ahead and I created something on Canvas for you. Oops, Canvas on you for you, so that you can just copy and paste this in. So if you go to modules right now, and you scroll down to Module 8 Lab, you see the correlation table to copy and paste. It's an HTML document, and all you need to do is go on here, go ahead and copy everything that's in there, and paste it. Voila. So we created this is a correlation matrix. Now something to note about this correlation matrix, so it's essentially going to create a correlation matrix that looks just like this. And what we do is we're creating a new object called core_mat. It's going to be the matrix and the concatenate function, and we set up all of our matrix. Now the number of in columns is that in total value that we created, so it's going to be 5. And we say by row equals true. So if we run this, we're going to have a new matrix in here called core_mat. So correlation matrix is what that's short for. So go ahead and press play, and voila, we have a new new matrix that is all of our correlations in it. And again, this is a matrix. It knows that all of these are numeric values, and that's going to allow us to do matrix multiplication on it later. Okay, we're going to go ahead and save that. So we created the matrix. So let's go ahead and create, and again, I know this should be a second level header. Let me make sure. Let's go ahead and create a third level matrix, third level header. We're going to go ahead and view the matrix and its parts. So what we're going to do is create a lot of new matrices here. So what we're going to start off with is do RXX, and this is going to indicate, so this is going to be the correlation of the x variables. So RXX is going to be in our assignment operator. We're going to do core_mat, C-O-R-M-A-T. So we're pulling from this core_mat and we're indexing our variables. So it's going to be, what we're going to say is we want 1 in x, which is 1 to 3 of our variables, comma, so we want rows 1 to 3 and columns 1 in x, which is columns 1 to 3. And if we run that, we're going to get a new matrix called RXX, which is going to be the correlation of all of our x variables. And what I mean by that is the correlation between x1 and x1, x1 and x2, and x1 and x3. So essentially, all of these variables right here, we're going to pull out that part of it where x variables correlate with the other x variables. So we can go ahead and do that. We can go ahead and run that line of code. And voila, so we have RXX, which is just the x variables correlated with each other. Now, we're going to go ahead and pull out the correlation of just the y variables. So the correlation of the y variables. So again, now let's go ahead and name this object RXY. And then we're going to go ahead and use our assignment operator. We pull from our core_mat, which is our correlation matrix with all of the numbers in it. And then we again use indexing again. This time, we're going to use that first y to tell it where to start. So first y colon in total. So it's going to say go to the very end of the matrix, comma. So this is all of the rows. This is going to be rows 4 to 5. Then we want it to do first y, so get column 4 to in total. which is going to be columns 4 to 5. So we go ahead and run that. All right, so we have rxy, which is just the correlation of our y variables with each other. Then we want to get the correlation of our x's and our y's. So let's go ahead and hashtag get the correlations of the x and y variables. So these are only the variables. So these are only the places where the x's and the y's correlate with each other. So essentially, right in this area here. So when x1 correlates with y1, x2 correlates with y1, x3 correlates with y1, and the same for y2. And that's what we're going to be pulling here. So we create a new object called ryy, which is the correlation of the I'm sorry, this is going to be ryy essentially, not rxy. So that's the correlation of our y variables. And this is going to be the correlation of our x and y variables. So make sure you got that right. It's rxx, ryy, and rxy. And we go ahead and do our assignment operator. We go from a pull from our core mat matrix, and then we index. And here we want 1 to nx to the number of x's, comma, first y, colon, in totes. So what that's going to do is pull all the variables that are associated, that are relating x and y with each other. We go ahead and run that, and voila. And I'm going to go ahead and run this again real quick. There we go, just to make sure. And then we have this rxy. And this is where x is correlated with y. And we're going to be using these matrices later in order to actually be doing our multivariate correlation. So now we're going to move on to step 5, which we're essentially going to be calculating our multivariate correlation using this equation. So the first step is we're going to create the numerator, then we're going to calculate our denominator next, okay? So first thing, we're just remember that numerator is the correlation between your x and your y variables while incorporating the weights. So let's go ahead and do hashtag step 5. Calculate the multivariate correlation. We're going to go and insert a new R chunk. What we're going to do first is we're going to have to do something called transposing our matrices. So currently we have our C weight matrix, which is a 2 by 1 matrix. We need to convert this into a 1 by 2 matrix so that we can do our matrix algebra. We're also going to be doing the same thing to our T weights matrix, which is currently at a 3 by 1 matrix, and we want it to become a 1 by 3 matrix, okay? So the way we do that in R is we use a function which stands for transpose, but the function is just shorthanded, just t. So it's t with parentheses, and it stands for transpose. So let's go ahead and hashtag create a transpose of each of our weight matrices. So let's start off with our criterion weights that we created earlier. Remember, this is just the weights we want to add to our y variables. So we do C weight capital P. Then we do an assignment operator, and what we're going to use that transpose function, which is just t parentheses, and we do c weight. So we're currently going to transpose the c weight variable. So we go ahead and run that. We'll have a new object called c weight t. As you can see, our c weight one was like this, and our c weight t variable is now a 1 by 2 matrix. Now we need to do the same thing to our t weights variable. So we're going to name this t weight p. We're going to use an assignment operator. We're going to do transpose our t weights. I'm sorry, I know I pluralized that earlier. I wish I didn't pluralize it. This is going to be a 1 by 3 matrix once we do it. And here we go. Yep, it's a 1 by 3 matrix. And voila, we're going to use those later to calculate our numerator and denominators. In fact, we're going to do it in the same chunk actually. So let's go ahead and we're going to calculate the numerator of the multivariate correlation. Okay, and just to show you again, we're going to be calculating this part of it right now, okay? So it's the weights of x times the correlation of x and y times the weights of y. So what we're going to do, name this called our numerator. So any just shorthanded for numer. And then we're going to save it into an object. What we do is we're going to multiply our t, weight, t, and the way we do matrix algebra in R is we do a percent sign, asterisk, percent. And we're saying that we want to multiply using matrix algebra so that our matrix of t, weight, t times our correlations between x and y, which is rxy, times our weights of y. So we use this matrix algebra, which is percent, asterisk, percent. We want to multiply it by our criterion weights overall. Okay, so if we run this, we're going to get our numerator. Okay, voila. We have a numerator. So our numerator is 2.341. So now let's go ahead and get our denominators ready to go. So we're going to go and do hashtag, hashtag, hashtag. Calculate the denominator of the equation for multivariate correlation. Okay, go ahead and scroll down here. So the way we're going to do that, so let's go and look at this. The first thing we need to do is get the weights of our y times the correlation of our y's times the weights of our y's as well. So we go ahead and let's go ahead and name this variable var, the variance of y, and then we use our assignment operator. So it's going to be our c weights, e, so the transpose of our thing, use this multiplication in matrix algebra times the correlation of ryy times the criterion weights. Okay, so if we do that, we're going to have the y portion. So we just calculated this part of it without doing the square root. We'll do the square root later. Then we're going to calculate the x's. So we're going to name this variance of x, var x, use an assignment operator. And then we're going to do t, weight, t. And then we use times our rxx times our t weights. If we run this, it's going to be a new variance of x. So as you can see, we have var x and var y, which is 6.06 and 2.44. Now, so we went ahead and we just created this. Now we need to get the square root of each of these and multiply them by each other. So we're going to go ahead and name this denominator. So denom for short. We're going to take the square root, which is sqrt, parentheses, variance of y, times, and we don't need it, we aren't multiplying matrices by each other. These are just normal numbers, right? There's one variable matrix, times the square root of x, variable, variance x. Okay, and this is going to be our denominator. So we do that, denominator. So what we did is we just calculated our denominator here, and now what we're going to do is we're going to divide our numerator by our denominator. So the way we do that, to get that multivariate correlation, we're going to name it mult. We're going to go and save it into an object called multivariate value. And then we're going to do the numerator by the denominator. And then we're going to go ahead and run that. We have a new object called multval, and it just so happens our multivariate correlation is 0.608. So we have a multivariate correlation of 0.608. I'm going to go and spit that out, multval. Have that spit out for us. So 0.60. So what we're saying is the multivariate correlation, which goes all the way to the top, the correlation among all of these variables is 0.608. And that's all it is. So I know that was a little bit tough. There's a lot of different things to think of. But if you go through this slowly, you'll see how all these numbers are forming and able to be understood. So I'm going to have you do a little bit of practice with multivariate correlations and matrix algebra for your assignment today too. So if you go to your, whoops, that's my Facebook. If you go to your home, go to modules, and then module 8 lab. I have a module 8 activity ready for you. Okay? All right. Well, thank you so much for listening, and look forward to seeing your assignments. Thanks so much.